up to this point, I've been giving you the chemical formulas, and I just said, here's the reactants, here's the products, make it balanced, put the coefficients on the line. From now on, most of the time, I'm going to be giving you a sentence that says, this and this react to form blah, 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 blah. So you're going to have to use the sentence and the context clues in the sentence to actually write out the equation, then balance it, and include states of matter. Okay, so these are 3 points each. So there's some key words to distinguish how to distinguish between the reactant side and the product side. Okay, there's also key words to know, like when you put a plus sign and that kind of thing. Like if this reacts with that, that means you're going to have this plus that sort of thing. Okay, or some key words for the arrow would be like if it says combine to produce, or to form, or it decomposes into, or this is produced, the products are. That's telling you that you're done with the reactants and now all you have left are products. Okay? So somebody asked me this earlier. The arrow always points to the right. Every time. Without fail. Points to the right direction. Okay? And that's because the reactants come before the arrow and the products come after the arrow. So when we're reading through the sentences and I'm labeling R versus P, R stands for reactants, so that's going to go on the left side, and P stands for products, so it's going to go on the right side. Okay? The states of matter will usually be included in the problem too. So there'll be some key words for those as well. It might say aqueous, it might say gaseous, it might say liquid, it might say solid or metal or powder. Those are your key words to know states of matter. States of matter are not a part of the actual balancing equation. They're just labels on every part. Okay? So we're going to see that in our example. But what we do need to know is that acids are always going to be aqueous. Because sometimes I forget to tell you like a solution of hydrochloric acid. So you're just going to have to know when you see acid, you're going to label that AQ. Okay? And then when we label the states of matter, we put them in parentheses so that you know that it's not a part of the balancing. It's just a label there. Okay? So we're going to do examples 4 and 5, and then we're done with notes. Okay? Here we go. Example 4. Hydrochloric acid reacts with solid sodium bicarbonate. The products formed are aqueous sodium chloride, water, and carbon dioxide gas. So, the first thing I like to do is figure out my reactants and products so I can kind of plan what it's going to look like. Okay? So, hydrochloric acid reacts with solid sodium bicarbonate. If they're reacting with each other, do you think those are going to be reactants or products? Reactants, because they're reacting, right? So, hydrochloric acid, I'm going to label an R. And for solid sodium bicarbonate, I'm going to label that R. So those are both reactants. So the words react with is our key word to know they're adding together. So we're going to put a plus sign in between the two. Okay. Now, the products formed are. When we see that, does that mean that we're going to have any more reactants? No. So the products formed are is our key terms to tell us that's where the arrow is going to be. So I'm going to just draw my arrow to remind myself that now I have my arrow, so everything else after is going to be a product. So we have sodium chloride, that's a product, water is a product, and carbon dioxide is a product. When we write those out, are we going to jumble them all together in one big thing, or are we going to separate them? Keep them separated. So we separate them using plus signs. So it's going to be sodium chloride plus water plus carbon dioxide. And yada yada yada, there's nothing left. So we have 2 reactants and 3 products to make up our equation. Okay? Now we have to start writing them correctly according to our naming and formula writing rules from chapter 9. So, first one we come across is hydrochloric acid. HCl. If you didn't remember, at least maybe you remember that H's start acids. It's hydro, so that means it's from the periodic table. So HCl reacts with, next we have sodium bicarbonate. Na is for sodium. What's the charge on sodium? Plus 1. And bicarbonate is a polyatomic ion. Bicarbonate, not carbonate. Hydrogen carbonate, bicarbonate. HCO3 -1. So, remember back when we had to balance our charges charges to 0, those cancel out, right? So it's just going to be NaHCO3. Okay, so that takes care of our sodium bicarbonate. Next, we have the products formed, so there's our arrow. Sodium chloride, what's that? NaCl. Cl is -1, so that's why it's okay. Plus water, what's that? H2O. Plus CO2 for carbon dioxide. Alright. It's really hard to balance the equation if you don't have it written correctly. So at this point, if you would like to stop and look at the answer key to make sure you wrote it down correctly, you're more than welcome to do so. Okay? This is 1 out of 3 points, because we've written it correctly, but we have not seen if it's balanced, and we have not done states of matter. So which would you guys like to do next? Balance sounds great. Do you guys need me to show the work for this first one? I will. Okay, so we have H, we have Cl. Remember, you don't have to show this work, it's just if you need to right now, you can. Then we have sodium and carbon and oxygen. Okay, on the left side, on the reactant side, how many H's do I have? 2, because I add them together. How many Cl's? 1. Sodiums, carbons, and oxygens. Okay. On the product side, how many H's? How many chlorines? How many sodiums? How many carbons? And how many oxygens? 3, because we have 1 plus 2 to give us a total of 3. So is it already balanced? Yes, it is. Some people got minus like a half a point on their problems because they didn't write the word balanced. So if you are not given blanks, like you were not given blanks today, you need to write the word balanced to show me that it's balanced. Okay? Even if you show this work, you still have to write the word balanced. Because if you show the work, that doesn't mean you figured out that it was balanced or not. I need to see that you know for a fact that it's balanced. Okay? So now we have 2 out of 3 points. Third point comes from states of matter, which some of them are given in the words, and some of them we just have to infer. Okay? So the first one we have is hydrochloric acid. All 5 of these, by the way, need a state of matter labeled on them. Okay? Not each element, each compound. So what was my hint to you right before we started? What's acid going to be? Always an aqueous. So we put a little AQ somewhere around that. You can put it to the right of it. You can put it underneath it if you don't have space. You can put it above if you need to. But AQ for aqueous for acid. Okay. Next we have solid sodium bicarbonate. It tells us right there that it's a solid. So we put a little S after it. Then next the products formed are aqueous sodium chloride. So NaCl is going to be an AQ. Water doesn't say anything. What do you think the state of matter is going to be?
Liquid.
A liquid, exactly. That's a L, Carciphy L. Remember, the definition of aqueous is something dissolved in water. You cannot dissolve water in water. So that's why it's a liquid. And then carbon dioxide, gas. So now we have gotten our 3 points for this problem. Okay. We have one more example and then we're done. What? Yes. Notice how each compound gets a label, not every element gets a label. Okay? So let's do example 5 and then we are done for the day. Is it okay if I erase? Alright. This one's a lot less work. Okay, sulfur burns an oxygen to form sulfur dioxide. Kind of forgot my states of matter here, sorry. Sulfur burns an oxygen. If they're burning together, are they reactants or products?
Reactants.
Reactants. So sulfur is a reactant, oxygen is a reactant. Burns in is another term to tell you you're adding them together. Okay. Then we have 2-form. What does 2-form mean? It has the arrow. And then sulfur dioxide is after the arrow, so that's our product. Alright, in this example, it's important because I'm showing you when you have diatomic molecules, aka oncofibers, okay? So we have to look up at the poster. Whenever you have something by itself, so not when it's in a compound, when it's by itself, So like if I said sodium metal, or oxygen gas, or hydrogen gas, or something like that. So an element by itself. You have to see if it's honkel fiber. If it's honkel fiber, you have to put a 2. If it's not on the list, then you don't put the 2. So, sulfur is our first one. It's not like sulfur chlorine or something like that. It's just sulfur. Is sulfur on the list? No. So it's just going to be an S. Oxygen, is that on the list?
Yes.
Yes, it is. So we're going to have O2. Okay. Then we form sulfur dioxide. What's that going to be? SO2. It's like carbon dioxide, but you substitute sulfur. So there's 1 point.
So it's already balanced.
It's already balanced. I'm not going to show the work, but we have 1 S on the left, 1 S on the right, 2 O's on the right, 2 O's on the left. So it is already balanced. To get my point, I have to write the word balanced. Okay? You don't have to underline it. I just like to. And then, states of matter, which I'm just going to give it to you because I forgot to give it to you on there. Sulfur. Has anybody ever seen sulfur, pure sulfur before?
Is it a solid?
It's a solid. It's like it's a yellow powdery substance. Kind of chalky. Smells bad.
Yeah, it does.
Oxygen. What do you think that's going to be?
Gas.
It's a gas. Oxygen is oxygen. Yes. And then sulfur dioxide. Who wants to guess? It's a gas. Yep. So there's our 3 points. And that's it.
I'm not surprised, not everything lasts.